Trigonometric functions using the fundamental identities. So our fundamental identities will be found on this piece of paper that was provided to you. And I'd like you to highlight both the primary functions and the secondary functions above, and then these identities. Okay, so the key is here, we do not want to draw a triangle. So how can we achieve this without drawing a triangle? So I'm looking and I recognize that we have cosine. Cosine can be found in this first trig identity. So I'm going to grab a piece of paper that allows me to show my work. Just not enough space for me in the provided area. And I'm going to write down sine squared theta plus cosine squared theta equals 1. Where did I find that? That's from the provided identities we are given. Now I'm going to replace cosine with -4/5. So sine squared theta plus, and I'm going to write it twice because when we expand it, squaring it means writing it down twice. We're multiplying it by itself. Two negatives multiply to give you a positive. 4 times 4 is 16. 5 times 5 is 25. And now to isolate the sign, I need to move this to the opposite side. Opposite of adding is subtracting. Okay, so without using a calculator, I can find a common denominator by going times 25 times 25. I have 25 over 25 minus 16 over 25 equals sine squared theta. 25 subtract 16 is 9. And then I'm going to take the square root, and I should get two answers. We're going to come back to that a little bit later, but I should get two answers. The square root of 9 is 3, and the square root of 25 is 5. But let's look back up to this original problem. It says that the sine of x, or the sine of theta, has to be positive. It has to be greater than 0. So I'm going to cross out the negative portion. And now I'm going to go to sine and write 3/5. So sine is 3/5. That means its reciprocal, cosecant, would be 5/3. If the primary trig function is positive, the secondary will also be positive. Cosine is -4/5. That means its reciprocal will also be negative. Now, how do we find tangent? I can see that tangent, well, we don't even have it here. Let's see if it's anywhere over here. I don't see it. I'd like you to add this here, please. Go up to the very top and please write this. Tangent of theta is equal to sine of theta over cosine. And please write down that the cotangent then is equal to the cosine over the sine. Okay, you ready? So tangent is equal to sine over cosine. So my sine tangent of x is equal to sine divided by cosine. And I'm going to write these horizontally. So I'm going to write 3/5 divided by -4/5. When we divide fractions, we're going to change division into multiplying, and we're going to flip the second fraction, taking their reciprocal. These are going to simplify to 1. I have 3 times 1 is 3, 1 times 4 is 4, and don't forget about the negative sign. So the tangent of this x is -3/4. That means the cotangent is -4/3. Let's look at number 2. Number 2 is a little more confusing. So ultimately what we need to do is we need to figure out how can I use this given information and apply it to each individual problem. So the cotangent is positive, and it's 4 or 4 over 1. That means its reciprocal tangent will be the same sign, but we're just going to flip the fraction to 1/4. Let's also keep in mind that we know tangent is sine divided by cosine. So if these two values divide to give you a positive, one of two things has to occur. They're both positive or they're both negative, because two positive values produces a positive, and two negatives when you divide produces also a positive. So these are going to be the same signs. Okay, now we need to do this without drawing anything. So I'm going to look at tangent and cotangent. Let's see, which one do I want to use? I'm given cotangent. You know what? I think I'm going to use this particular Pythagorean identity. So I'm going to write it down right now on this piece of paper. So cotangent squared plus 1 equals cosecant squared. And then I'm going to put it in. It's 4, so this is 4 squared plus 1 equals cosecant squared. 4 squared is 16. 16 plus 1 is 17. I take the square root. I'm going to get 2 answers. I'll decide later is it positive or negative. And then I go up to the very top and I can see that the sign has to be less than 0. That means the sign has to be negative. If sign is negative, it means its reciprocal, cosecant, must also be negative. So I'm going to write negative radical 17 for the cosecant. The sign will be the reciprocal of this. So let's come off to the side. The reciprocal is just simply going to be 1 over negative radical 17. Now that's not mathematically wrong, but we have to write it in a proper form. So times radical 17 times radical 17. I have 1 times radical 17, that's 17. And square root of 17 times the square root of 17 is simply 17. What do I do with this negative sign? It can go on the top, on the bottom, or in the middle as long as there is 1 negative. So there's my negative square root of 17 over 17. Now before I figure out what is the, let me grab another piece of paper. Before I figure out what is the cosine and the secant, I can already determine their signs. If sine is negative, then cosine must also be negative to produce a tangent that's positive when you divide. So I'm going to put a negative sign in there right away. All right. So what am I going to use here? I think I'm going to go back to using sine squared plus cosine squared equals 1. Here we go. Sine squared theta plus cosine squared theta equals 1. I know what the sign is, so I'm going to replace negative square root of 17 over 17. And I could write squared, but I know that really means taking it times itself one more time. So I have sine squared plus cosine squared equals 1. Negative times negative is a positive. The square root of 17 times the square root of 17 is simply 17. And then I'm not going to multiply 17 times 17. I'm just going to write it down here, 17 times 17. Oftentimes, we use the term cancel out. What we need to recognize is that when these reduce, they reduce down to 1. 17 divided by 17 is 1. 17 divided by 17 is 1. So I'm left with 1 over 17 plus the cosine squared theta equals 1. This is positive. When I move it to the opposite side, I'm going to subtract. And now I want to find a common denominator here. So I'm going to go times 17 times 17. 17 over 17 minus 1 over 17 equals the cosine squared theta. 17 minus 1 is 16. And I take the square root. I would have 2 answers here, both positive and negative. The square root of 16 is 4. The square root of 17 is irrational. We need to make it into a pretty or a proper way in just a second. But remember, we've already determined that the cosine is negative. So I'm going to cross out the positive. Mathematically, this is not wrong, but it's not in proper form. So I'm going to multiply it by the square root of 17 to get 4 square roots of 17. Square root of 17 times the square root of 17 is simply 17. And don't forget the negative sign. Okay. All right, so here we go. Negative 4 square root of 17 over 17. Negative 4 square root of 17 over 17. Now, what's the reciprocal of this? Remember, this is what I had right here. I had negative 4 square root of 17, and I said mathematically that wasn't wrong. It just wasn't proper. So I had to rationalize the denominator. If I take this cosine and I flip it around or find the reciprocal, I'd have square root of 17 over 4 with the negative. This is the reciprocal of this, so I can place this into the secant position. Negative square root of 17 over 4. Look right now at number 5. What can I do? So I'm going to find cotangent, and Jeremiah noticed that although I put this up above, it was already here. So cotangent is cosine over sine. So let's rewrite this. Cotangent is cosine, whether I put a theta or an x, doesn't matter, over sine. Tangent, we can see, is sine over cosine. Okay, So this is a perfect example where if you just use the words cancel out, if they disappear, that would be wrong. Remember, they're going to simplify to 1, and this simplifies to 1. 1 times 1 is 1, 1 times 1 is 1, and we get a final answer of 1 when I reduce this. So cotangent of x times tangent of x is equivalent to 1. Let's look at the next one, secant squared x minus 1. So I'm going to glance up here, and I see secant right here, but I need to show my work. That's the key. I need to show my work and how I achieve this. So I'm going to write down this trig identity. Tangent squared x plus 1 equals secant squared x. Now, in order to get it in this form, I have to subtract 1 to the opposite side. So tangent squared x equals secant squared minus 1. This is what I have. We can see it's equivalent to tangent squared x. That same concept is for number 7. I'm looking at 1 minus sine squared. And I'm going to analyze the trig identities. 1 minus, okay, I can rewrite this first trig identity, and I can move sine squared to the opposite side to achieve the numerator. So let's write down sine squared x plus cosine squared x equals 1. Now, if I move sine squared to the opposite side, I have cosine squared x equals 1 minus sine squared x. This is what we can see in the numerator. So I can replace the numerator with cosine squared. And by the way, cosine squared simply means cosine of x times cosine of x. In the denominator, I already have cosine of x, or cosine of theta. I just need to keep them the same. All right, so I'm going to simplify. They turn into 1, and so I'm just left with cosine of x. Let's look at number 8. Let's look at number 8. Now, secant, forget about squared. Let's just think about secant. Secant is the same as 1 over sine. So secant squared is the same as 1 over sine squared. Let's write this down. I already have cosine squared, and I'm going to replace secant squared with 1 over sine squared theta. When I multiply, I have cosine squared theta over sine squared theta. Cosine over sine is equivalent to cotangent. So cosine squared over sine squared is equivalent to cotangent squared. Cotangent squared